No, I can't do it. Maybe I can. All right, wait. Before we do any questions, let's do this. I'm gonna create the formula sheet. If anybody's interested in that,
Sure.
we'll do that. And then we'll open it up to questions. Lewis? It's curved a little bit. Oh, Lewis, do you want a copy of the practice test? Or you have
I
it?
think I have it, but I'll take it.
Sure. By the way, guys, this is the formula from chapter 10. If you're not going to do that extra credit homework, maybe don't even write this on your formula sheet. You with me? But if you think about it, if you want to try it, then write that down. Okay.
That's the funnest one.
Huh?
That's the funnest one.
It's the funnest one? All right. This is Z-Star's Final Four. Actually, not really, but for us, yes. Is that even your final form, bro? Alright, that'll be fun. Alright, so this test, what's it do? It goes from chapter 8 to chapter 9, basically. 10 will be a bonus on there, so if you don't want to do the homework for that, this extra credit, you're fine. Chapter 8, of course, is all this stuff here, all the confidence interval stuff. I had a purple that worked really well. What happened to you? That's a little better. Ooh. So again, these two are like notes. You're not allowed to have notes. You're allowed to have formulas, so just treat the formulas like notes. What is it that these two tell you?
The spread.
These are formulas for confidence intervals. How are they notes? What does it remind you? When do you use a t-score?
Sample.
When you only have S. I use a z-score when I know sigma. Those formulas remind you about that. You guys see that? Yeah.
How would S be worded again? The standard deviation obviously says the standard
So
deviation.
you've seen the example like on the quiz. I'll say we talk to 87 people and we find a mean of 11 and a standard deviation of 2. That's a sample standard deviation because it came from a sample, right?
Yeah.
If you don't see words like the population standard deviation was, or the standard deviation for all tires is, or whatever, those are obviously population. If you don't see those kind of words, it's a sample standard deviation. Right? When in doubt, assume it's a sample. What's the one that comes right after that? We actually learned the second one last. What's the other confidence interval?
P hat.
Yeah. So p hat, give or take z square root, bunch of hatted ones. And this is where you guys get in trouble. Obviously, double check what you think I'm writing with what it actually is. And that's one reason why I give you a lot of handouts. It's got the formulas written by a computer, so you can actually read them. 2 more formulas came out of chapter 8, and actually it's 3.
N equals.
Yeah. So this one is kind of nice, z sigma over e squared. And then we've got n equals, there. Z squared p hat q hat over e squared. Become an e.
I got T.
What if I ask you, ooh, how low can you go? What if I give you, ask you a question about how many, but you only know S? You would use this formula, you would use an S here, and you'd have to use a T there. So if you want to, you can write down n equals TS over E squared, but I really want you to understand the same stupid formula. They're the exact same formula. All right. Okay, so that's chapter 8. Chapter 8's got all that mess there. It's kind of nice. You got one of these for each one of these, right? Bam, 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 bam. Okay. And then we get to chapter 9, which doesn't really give us new stuff until we get to the percentage stuff. So if you want to, you can certainly write down like Z star, sigma x bar equals sigma over square root of n. You could write down T star over Sx bar equals S divided by square root of n. Oh man, this is our longest one yet. So it doesn't matter if it's S or sigma, those are both the spread of individual data points. In those cases, I need the spread for groups of data points. So I have to change it no matter what.
What is that?
I don't know.
The first one?
This here,
Yeah.
that's sigma x bar.
Oh, okay.
Is that better? Relative to how I write, that's pretty good. So we got one more formula. It's the most recent formula we came up with. It's the one for p hat. I have to put it over here. And for this one, we stole the standard deviation from this formula right here, because that's the standard deviation for groups of that we get percentages from. The only difference is we don't have to use the hatted ones because we're assuming we know the real percentage p. Anything else you think should be on your formula sheet? And again, if you did not do section 10.2 and you don't plan on it, then don't even write this. But if you want to write this down, if you want to try the bonus question from that section out, you can write it down in your formula sheet. Otherwise, don't do it, because they'll just sit there and freak you out. Right? And by the way, this formula here is, if I take two samples, for example, I want to prove that our new drug works faster than the old drug, right? So what do? I get a control group, and I get the actual group that's going to get the drug, right? Or maybe a placebo group and the group that gets the drug. Isn't my placebo group a sample? And isn't my group that gets the drug a sample? I have two samples. If I want to show that my drug works faster, then I want to show the difference between the two sample means is relatively large. Does that make sense? So I'd want to show the difference between the sample means relatively means in terms of standard deviation. Now the bottom here, I don't want to spend a ton of time on this because it's bonus. If I just cover this up, what's the square root of sigma squared? Sigma. And what's the square root of n? Square root of n. So sigma over the square root of n, that's just our normal sigma x bar. Here, everything's freaking doubled because I have two of everything, right? So basically, this is the same stupid formula, it's just everything's been doubled. Normally I have one x bar, now I have two. The reason there's no mu's is because our null hypothesis is normally that mu1 equals mu2. That would cancel. That's as much as I'm going to say about it. It's a bonus section. Okay. All right. Sorry for blocking. Somebody got all of that? Anything you think I left out? Anything else you think should be up there?
No.
Okay. Good. I agree. I always am understanding that I am just a human. I could very well forget something easily. Jennifer. You need a copy of the practice test?
Yeah.
You got it? Yay! All right, guys. Yes.
Can you review number 1 on the practice stuff?
I will. Let me just make sure I've got all this stuff. For those of you at home. All right. I need to reclaim my board, so if you just came in, maybe grab somebody else's, see if you can copy from them real quick. Is everybody else good? I'm going to start erasing and see if anybody yells at me.
Good.
Okay. All right, so the question is from chapter 1. I'm sorry, number 1 on the
Practice test.
practice test, yeah. Okay. So everybody read through that real quick if you haven't tried this out yet. And again, if you need a copy of the practice test, I have some up here. So the very first thing I ask for is to check for normality, right? And what tells me that this is normal enough?
Greater than 30.
Yeah, sample size is big enough, right? The next immediate thing you should be concerned with, so you know it's normal, that tells you can do something. What is the next thing you have to determine? Z or T? So which one is it going to be and why? If I said it's Z because I know the standard deviation, what's wrong with that?
Which?
Yeah, the whole thing is which standard deviation. Like you said, it's the sample standard deviation. Does everybody see that? I didn't say sample standard deviation. Of course I didn't. You need to read from context. Where did that standard deviation came from? It came from the sample. In which case, what do I have to use?
T.
T-scores.
I have an idea.
Yeah. All right, let me stop for a minute. All right, so you asked the question, what else after that is in trouble? So now you know what's alpha for number 1. Forgot what it was. What's alpha? 0.02, 11. Confidence intervals always make 2 tails, right? So if you look at 2 tails, 0.02, and you're going to stop where? What's the degrees of freedom? 31. Everybody with me? Let's see if we can all find that t-score. Don't say anything. Alpha is 0.02. Confidence intervals make 2 tails. Degrees of freedom is 31. What's the t-score?
2.453.
Okay. I agree. And then you just throw all that stuff in the formula, right?
Okay.
Yeah.
Cool. Thank you.
Now, a similar kind of problem is number 6 on the back. But the difference on number 6 is I didn't just give you X bar and S. The first thing you need to do is throw all that stuff in the calculator and calculate it yourself. Don't get overexcited and see that there's a sigma. Your calculator will always give you sigma and S because they're dumb. They're really, really dumb. It's not your fault. You have no brains, thankfully. You guys all with me? So we have to know which one to pick. And of course, for number 6, those are both samples, so we have to choose S, which means we're going to have to use t-scores, right? Now, are those sample sizes big enough on number 6?
No, but it says normal.
Yeah, yeah. So either it says it's normal or the sample size saves our ass, right? Yeah.
When we get that sample standard deviation from the one verse stats, do we use that, or do we have to put that over the square root of?
So you're going to calculate X bar and S, correct?
Uh-huh.
Now, what's the formula for the confidence interval?
Plus or minus T.
S over the square root.
The great thing is it's built in, but this is a great place to show you, shit, yeah, of course you got to divide by square root of n.
Okay.
Again, S and sigma. We all agree those are different, but they both measure the same thing, correct? So what do they have in common? They're the spread for individual data points. One is calculated from a population, the other one's calculated from a sample, but they both measure the same thing, the spread of individuals. When I'm doing a confidence interval, I have taken a sample, a group of things. I now need the standard deviation for a group of things. That's what this does. So I don't give a shit if it's S or sigma, they both have to be changed. And this one's built into the equation. So you almost can't go wrong. The worst thing I see people do is they'll calculate this, they'll do this, they'll take that number, they'll put it in, they'll divide it again. I'm like, oh God, no, don't divide the poor dude twice. Poor little dude.
So when you get the S of X on one verse stats, it's not over that yet.
Yeah, and it's kind of unfortunate, but again, this just means the standard deviation of the X variables. If you put in list 1 and list 2, guess what it would have? It would have SX and it would have SY. So it's differentiating between the standard deviation of the stuff you put in the first list versus standard deviation of the stuff you put in the second list. SX, SY. You guys with me?
And we get that data separately and then compare it.
And how does this relate to what this is? What's the symbol for this? That's the formula. What's the symbol for it?
Standard deviation of the sample.
Sample mean. See how that's not the same, yeah? This is the standard deviation for each individual data point. This is the standard deviation for groups, for means of groups. Okay, like it. They might be. So confidence intervals are nice because it's built into the formula. Hypothesis tests, you have to remember. Whatever the shit standard deviation they give me, I got to divide it by square root of n to make it a spread of groups. That's what it does. Okay. Okay. Just to remind you guys, we've had 2 other review days. It's completely.
Do you have a calculator?
I do. If you need to borrow a calculator, I got some. Do you have anything for me?
Yeah.
Thank you. Thank you so much. Sure. Oh. Yeah.
Can you do number 75 on the homework, Professor?
I don't know. What section are we talking about?
9.5.
You said 75? What'd you say?
75,
75?
section 9.5.
Sure.
Thank you.
All right, let me throw this up here. Oh, multimedia. Someday. All right. Pretend like that actually did something. All right, 75. I love the way this starts off. From generation to generation. Think about Morgan Freeman. From generation to I can't. The mean age when smokers first start to smoke varies. However, the standard deviation of the age remains constant. I doubt that, but for the purpose of this problem, we'll just agree. 2.1 years. What symbol would you use for that? Totally, it's the standard deviation. What symbol would you use for it?
S.
No.
Did it come from a sample? Sigma, yeah, it's sigma. That's a known standard deviation. They don't say it's about any sample. They just say it's the standard. So that's sigma. Survey of 40 smokers, blah, 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 sample mean, sample standard deviation, blah, blah, blah. So one big deal with this problem, and of course I like this problem. They give us 2 standard deviations. This one's sigma. Does everybody agree that that one is definitely freaking S? Because where did it come from?
Sample.
It came from a sample. Okay, I love it. Which one do we use? 2.1 or 1.3?
Always sigma.
Always sigma if they give it to me. I really want this to make sense. If I give you sigma, we would use that, correct? Any sample I take, if it's numerical, can't I always calculate S whenever I wanted to? So if I calculate it, it doesn't suddenly mean that I can't use sigma anymore because I dared to calculate S. No. If I know both, I'm going to frickin' use the better one. So why is sigma better than S?
It's greater.
Because it's Greek. No.
Greater, wider. Sample could be off. Like
Sample could be off. S is always just an approximation for sigma. So of course if I know sigma, I'm going to use it. So the number I would never use in this problem is 1.3. Do you guys see that? So it's a little evil because they threw in a red herring, right? You guys understand that phrase? Is that a known phrase still? Red herring? All right, who knows what a red herring means? Real quick. Yes. You know what red herring means?
Yeah, it's like a smoking gun. Or like,
No.
something that sticks out like a sore thumb.
No. Red herring, who knows? It's related to a fallacy, sure. Anybody ever watched the movie Clue?
No.
Oh man, all right. Two things you should do. Watch frickin' Clue. It's one of the best damn movies ever made. I know it's an old man telling, watch this movie. It's really good. But it's really good. It's stupid good. Tim Curry's in that bad boy. I mean, come on. It's got so anyway, sorry. Red herring just means something that's not related to the current discussion. So 1.3 is a red herring. It doesn't matter. I don't care about it. I didn't need to know it, right?
Oh.
So therefore, are you going to use t-scores or z-scores in this one?
Z.
Z, because we know sigma. And also, of course, it's normal because what? Why is this normal? Normally distributed.
Sample size is more than 30.
And it's 40 greater than 30, kick ass. Okay. Gotta rewatch Clue. It's a kick ass movie, you gotta watch it. Come on. Anyway.
Is it related to the board game?
Huh?
Is it related to the board game?
Yes. So, yeah, it's got Professor Plum, it's got all these people, Colonel Mustard, blah, blah, blah. Yeah, okay, sorry. We'll let go of that movie. Is that all right for that problem, Charlton?
So far.
Okay.
But then when I set it up, the whole is the claim, which is the.
Well, wait a minute. Can you guys, anybody look at this? Charlton, hang on. What is the claim that's being made in this problem? What's the claim? It was number 75. It's up there. It's way over there. I don't know. Pause your video and zoom in.
That the standard deviation age remains
Huh?
constant to follow.
No. Where's the claim? That's something we know. I'm not making a claim about that. They just told me that's true. I'm not making a claim about that. Who's making a claim? What is it? Why are they doing the test? What are they trying to see?
Smoking.
They're not trying to see smoking.
5%.
What are they trying to see?
Mean age.
What about the mean age?
At least 19.
That's the claim right there. A survey is done to see if the mean starting age is at least 19. That's your claim. That's what they're testing. How do I write that in Mathfish?
O equals
No, just the claim.
M less than or equal to 19.
Yeah, at least 19. Be careful.
At least.
At least.
Oh, it's greater than.
Greater than or equal to.
Greater than or equal to.
All right, now why is that the ho?
Because it's got the equal.
Because it's got the equal sign. What's the ha going to be?
Less than.
Yeah, so now you know how many tail test, you know where that tail is. So be really careful about at least, at most. Just take a second. At least, you have to be at least this tall to ride the ride. That or more. That or more. At most, you could be at most this old to eat off the kids' menu. So that's up to, right? So that's basically less than or equal to at most. Okay. You guys with me? And again, your brain sees the word least and thinks less than. But at least means that or more, right? I know. Again, it's the English language's fault, not math's fault.
So then my tail is to the right.
Yeah, well, less than.
To the left?
Yeah, less than.
But the claim is the hoe.
I don't give a shit. So again, the claim gets us started, right? The claim gets us started.
Uh-huh.
I put that in the right place. I've said this several times. Which one of these can we actually show evidence for? The ha. We can never show evidence for something equaling something. We can't. If I took a sample and I got the average to be 11, is that evidence the real average is 11? Nope. Nope. I don't know. Sample. Shit. Could be anything. This is the guy that always sets up where our rejection region is, because the ha is always the one I can show evidence for.
So that would be negative 1.645.
Yeah, whatever the hell it is going to be on the lower side. Yep. Less
So if my z-score is negative 1.645, okay, and then I'll just calculate it and find the z-star
Yep. Cool.
using the standard deviation from the population.
Totally. So don't use 1.3 in this problem. Again, we've all learned something today completely unrelated to statistics. Red herring means irrelevant information. Yes? Sure. Or if I can't, then we're all in trouble. So this is this one. I keep using this one, and I'm sorry if you're tired of it. Too damn bad. Pain reliever, blah, 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 blah. Which step did you have trouble with? Or just from the beginning? Okay. All right. So can somebody tell me the claim in this problem that's being made?
But the new drug will give relief in less time than the old one.
All right, so it's in English. The new drug will give relief in less time than the old one. What's that look like in Mathish? This is number 3 on the practice test. Yeah, so the claim is that the mean of our new drug stuff is less than what? 16.1. Kick ass. What number would never show up in the hypotheses? That shows up later. It's a weird question, but let me just say this. 13.7. I would never make a claim about, because it's 13.7. I can see it in my sample. I would never make a claim about 13.7 because that's what we got from the sample. We're making a claim about this thing. Because I don't know what my new drug, how it compares, so that's our claim. Right? And we want to be able to do this so I can make a commercial saying it's been clinically proven to take your headache away in less time. That's what clinically proven means. This shit. Okay, maybe. So again, is that going to be the null hypothesis or the alternate? Yeah, because it does not have a equal sign. I always get people, they rush through the first step. The writing down what the claim is one of the most important steps, because if you write it down wrong, everything's wrong after that. Now, the way I grade is you'll lose points if you write the claim wrong, but then I'll grade the rest of your work assuming that what you wrote down is right. Does that make sense? All right. But yeah, you got to take a moment, really make sure you find the claim and really make sure you write it down correctly, because it's the thing that gets everything started. Okay. I don't know. Do you want to do the whole thing?
Yeah.
Okay. All right. So what about, will it be a one tail or two tail?
One tail
Yeah, one tail's going to be down there.
to the left.
Okay.
So is that, the tail's always dictated by the hawk?
Totally.
Oh.
So there were a few choices to be made when we developed this process. And the way we chose was whatever goes next to the ha is the thing I can actually show evidence for. In order to achieve that, it can never have an equal sign in it. So that kind of boils down to the shortcut method. Write the claim. If it's got an equal sign of some kind, put it next to the hoe. If not, put it next to the hoe. Command. Then I don't care what the claim is now. See, it gets us started, and I worry about it at the end, but in the middle, I don't give a shit. How do I do the second thing? Z or T?
T,
Why?
because it's a sample.
You gotta be more specific. So two things you gotta tell me here. What tells me I can do something?
Normal.
Why is it
Over
normal?
30.
Yeah, so n equals 42. Greater than 30. Check.
Sample standard deviation.
Yeah, we don't know sigma. Only know S, so we have to use
T.
t-scores. Alright. Sorry, that side of the room. I should have like curved whiteboard.
Okay, we got it.
Well, I think maybe somebody else is here. What about part C? Now we know it's a one-tail test. What's alpha? Oh, 1 of 5. And what's the degrees of freedom?
41.
Yeah, 41. Now what's freaky about 41 if you look at your t-score chart?
You gotta go to 40.
Yeah. Where'd it go there? You don't have the 41 on there, right? So where'd it go? 40. So in your t-score chart, what's the t-score when you look at degrees of freedom of 40? Because that's the next best thing we got. What is it? I got the answers.
One.
Wait, it was 8.4.
What is it? 2 point what? 1.684? Alright, let's see.
Yeah.
Does that make sense, Jeff? Yeah, let's say pass Jeff, man. You said too bad for pass Jeff. So what would it be exactly? Be careful.
1.684.
No?
Negative.
Negative.
Oh, negative.
Why is there
Because it's
a-
down
it's on
there.
that side? Okay.
Yep. Interesting. Alright. And then you just have to, now we've set up visually where the rejection region is. Can you write the statement?
If
What was that? Maybe. Oh, that's what he did. I love it. Oh, I did that part right, I think. If Z star is T star? T star is less than negative 1.684, we reject null support. Aha. Okay. All right, now everybody take a minute who wants to play along and do the next step.
That's for C.
Sorry?
Yeah, that's for C.
You can't see.
That's for C, yeah. And again, I got all this on my answer key, so. But apparently I made a mistake. Let's see. Yep, okay. I know what I wanted to have happen. It's too bad, Jeff. Okay.
Did Jordan pass out the answer?
No. No, I never give that out too early.
Do you have another practice test?
Yeah.
I mean, like another version?
No. Let's see. Yeah, part D. Oh, this is what threw me off. Okay, because I changed this. It was originally it was going to be a Z problem, and then I decided to make it a T problem. So step D, it says find Z star in the p-value. I don't know if you guys remember this, but I said I would never ask you a p-value for a t-score because we'd have to get that through technology. And I don't like technology. No, I don't like technology while you're learning shit. Okay. So we are finding t star. What do we know from the sample? What's x bar? 13.7. S is
16.1.
no. S is 5.94. So S x bar 5.94 divided by square root of
42.
42. Is that cool, everybody? So change the standard deviation and then make a t-score out of it, right? You guys all with me?
Wait, so to find T star, we use X.
Yeah, t star. It's the same formula as z star, just it's a t because it's got to use an s. That's all. That's really all those are. T is z. It's just z when I have to use s. So they all show up in the same place in the formulas, and they all mean the same thing. It's just I use z if I have sigma, I use t if I have s.
What's the star?
Hmm?
Why is there a star?
Because we already have a t-score. So crazy ass Jeff, this is my own thing. You don't have to do this if you don't want to. I just like to call it t-star to differentiate it from the t we already have. Yeah. So this will be 13.7 minus 16.1 divided by whatever the shit that is.
0.9166.
0.9166 or 917? Okay. So you can use more than 3 places, but you have to use at least 3 places. Right?
If we use 4 and it gives us a slightly different number than if, say, you calculated using 3, will you count?
I have both
Okay.
when I have make a key, yeah. So I'm ready. I'm ready for either way.
Thank you. Negative 2.618. P-value 0.004.
P-value you can't find. Because you'd have to use a z-score chart, and that's not a z-score.
Is our
You can't
summary
cross over?
just the X equals?
No, this is a t-score. You can't use a z-score chart for a t-score. Sorry?
Is the summary just the X equals S?
Yeah, this is the little summary.
This counts as summary?
Yeah. So I'm just trying to give people a hint that this step is all about the sample stuff. Right. So right now, can you tell, did we reject the null or not? We got way the shit in there, didn't we? Negative 262 beats this guy. Easy.
So,
Yes.
So that means we could do what? We can
Reject
we
the
can
null.
reject the null or the O, support
Oh.
aha. So what got us started was the claim, and what gets us finished off is the claim. What was the claim? Which one?
2 drugs bring relief unless.
Which one was the no. Which one was the claim? Which one?
Mu.
The ha was the claim, right? Therefore, I'm going to use that language. We have found sufficient evidence to support the claim that plagiarize. Open your eyes and plagiarize. I'm sorry. We have found sufficient evidence to support the claim that blah, 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 whatever it was. Yeah. Our new pain reliever, so you can say it a lot of different ways. Our new pain reliever is quicker than the old one. See, there's another way you can say it. You don't have to plagiarize. You can just capture the idea, right? Now, I will say this. I had changed this problem around a few times, so I'm not going to beat myself up too much. My purpose was for this to actually make things different. But then I went back. Oh, no, I don't think it does. What
Yeah,
would
that's
the rejection region have been if alpha was 0.005 instead of 0.05?
Negative 2.69.
Oh, really? It does? Oh, cool.
2.6.
Oh, that's awesome. That's lucky. Let me see. What was it? 40?
41.
40. Well, 40.
Oh, yeah,
It's the
40.
best we could do.
Right.
So 2.704. Yeah, we would fail then. Either way.
It's not 2.690 with that T.
No, because we have to use 40.
Oh,
Even if it was this, is 2.62 further than 269? Even if it was 269, no. So if alpha would have been 0.005 instead. If alpha were 0.005, so look at 0.005, it's the first column, right? 005, one tail, go down to 40.
yeah, so it's not sufficient enough. So it does change, it goes from sufficient to not sufficient.
Oh,
See?
okay. I am thinking backwards. Yeah. So let's do this, right? If alpha had been 0.005, it would become 2.704, right? I really want you guys with me. Why did I put negative 1684 here? Because if alpha is 0.05, that's what it would be, right? What if alpha had been 0.005 instead? Wouldn't we have looked at the first column? And if we go to 40, 2.704 now, right?
Yeah.
Okay, so I did get that part. So 2704,
Further out.
we would not have made it far enough. Our negative 262 would not have been far enough. Do you guys see that? My point with that problem, and I'm surprised that works still because I changed it so it did, is it all depends on what your alpha is, right? So if somebody's alpha was this, then we found evidence. If somebody else's alpha was this, we didn't find enough evidence. And alpha is basically your own level of evidence that you require. So if you go into a field, and that field requires you to read through some statistical analyses, you're going to develop your own level of what's good enough evidence. Whatever that study is about. Right? And each person can have a slightly different level of evidence. Do you guys all agree with me? That's one reason why we have juries. Is to kind of like make sure that there's not any extreme people are kind of balanced out by the more moderate or extreme the other way people, right? I don't know if you guys all understand. Whee! Right? If you just had one person jury, just this one guy like, I don't know, I think he did it. Right? That would suck. It would all be totally based on that one person. We need to balance that out. So everybody would have a different kind of level of evidence that they would require. Since we are not yet in the real world, none of us are actually conducting any of these studies. They give us alpha because we haven't developed our own yet. Okay. Maybe. All right. On the actual, I'll show you this. On the actual answer key, I got this part wrong. And I think it's because I originally had this being a two-tailed test. And I just sort of like took that number over. So that's my fault.
What number is it? Oh, the drop.
The one we just did. Yeah, so I'll point it out again when I give out the answer key. Okay, anything else from homework, practice test, quiz, general questions? Otherwise, this is a really short day if nobody's got questions. You're all ready. It's awesome. I brought nothing. I'm just here to answer questions. Oh, sorry. Yes.
Can you do 5?
Sorry, your hand was melding into the background.
Yeah, I can. Oh, wait. Can you do number 5?
Yes, sure. Here we go. All right. Same stuff, right? Same stuff.
Same stuff.
So what's the claim? Go ahead and read through number 5 if you haven't done it yet. All right, let's see if past Jeff did this right. I don't know, past Jeff. Sorry? Oh, the claim? So you're saying?
Yeah, I just don't know, would it be less than or equal?
Nope.
No.
And this time I actually used the word claim, right? So what's the
No, I
claim?
know that's not what
The claim that the population percentage is, see, it's so easy to skip that word. That is the most important word in there is. Depends on which definition of is. Oh, yeah, equal to. Oh, if you're leaving, you might want to grab a answer key. Maybe two. Sure. All right. So what's the claim in Mathish?
M equals.
Careful. No. It's not a claim about a mean.
Oh,
P equals.
Don't get too down. It's okay. The important part is the equals part. But you have to be careful. Is it a test about a percentage or is it a test about a mean? And the symbols are important because if you write down the wrong symbol now, you might use the wrong formula later and get really lost. You're like, what's the freaking standard deviation? I don't know. I don't know either. I don't need it. You shouldn't be using that formula, right? So you want to really make sure you understand this is all about percentages. So is it going to be the ho or the ha?
Oh,
What'd you call me? Oh,
oh. Professor.
thanks for clarifying. And so I already did this. I'm silly. So of course the alternate would be not equal to.
You.
Okay. So then am I allowed to do something?
N greater than 30.
That doesn't matter. I don't care.
Well, P times Q.
No. Nope. Close. N times P. There you go. Because I know freaking P. I'm not going to use P hat. Why would I use P hat? I know P is 0.667, right? So N times P. What's N?
84.
Big old 84. Times 0.667. You get something nice. If I remember correctly. Well, maybe not. I can't remember now.
56.028.
Yeah, it's pretty close to nice. 56.028. And that is
Greater than 5.
greater than or equal to 5. And then, of course, NQ would be 84 times
0.333.
3.
27.972.
So what's all that mean?
Normal enough.
Which means what?
You could do the formula.
No.
You could use a.
Normula? Normal?
You could use a.
Madragula. Normal enough. Which means what? I'm allowed to use z-scores. Good. What if it wasn't normal enough?
Can't do it.
Can't do it. There it is. So it's z or nothing. Percentage problems are z or nothing. Which is another reason why there's only one formula for p hat confidence interval, but there's two for x bar confidence intervals. I really want this to make sense. X bar, if it's s, you got to use t. Percentages, there ain't no frickin' s. There's no frickin' standard deviation. We make our own standard deviation. That's one reason why we don't use t-scores for those. You're like, whatever, man. All right. So what about setting up the rejection region? What's alpha?
0.02.
Is it a one tail or a two tail?
2.
Yeah, because it's not equal to, that can go either way. So don't say anything. Take a minute and look up the z-score. Of course, you should look on your t-score chart for that z-score, because we are all insane.
Why are you putting greater than or equal to 5? Is that just a double jump?
Where is it? Oh, here.
Yeah.
Yeah, for means, it either has to say it's normal or n has to be greater than 30. for percentages, NP times NP and NQ, they both have to be at least 5. Yeah. So it's the same check. N greater than 30 for means, NP and NQ at least 5 for percentages. They accomplish the exact same thing. They tell me if it's normal or not. All right, you guys got this z-score?
Plus and minus.
2.326.
I like it. If you went old school and you looked at your z-score chart, you would get 233, and I would accept that because it's basically just this rounded, right? So take a minute, write down in words what this means. Don't say anything. So that would be the if z star something or other. That. Don't say anything. All right, so z star is. Go ahead, you can talk. If z star is, how do we get in here? Less than what? Negative 2326 or greater than positive 2326, right? So it's got to be either less than negative 2326 or greater than positive 2326, so it doesn't end up in the middle. And just to I know I've said this a million times. I forgot to have balloons drop the millionth time I said it, but it's too bad. We already passed it by. The null thinks it should be in here. If I take a sample, the mean won't be the same, or in this case, the percentage won't be the same as the supposed middle. It'll be off a little bit. We expect that variability. So it could be off by that much. So if I get anything in there, it's not evidence against the null because that's exactly where they thought it should show up. If I get out here, though, okay, that's unusual. Assuming the null is true, if I get out there, that is unusual. That is evidence that the null is not true. Is it proof? No, you can never get proof, ever. Too bad. That's what the life is like for a statistician. They're always guessing. But guessing based on some really good evidence. That's good. That's the best humans could do for almost anything. Okay. So again, what are we talking about? What can we use to talk about it? Where does evidence start? Did we make it far enough away? That's the next step. So then I got to calculate what formula do I want to use? C star, good. Which one of those? There's many, or there's a few. Probably the one that's got p's in it. So I want to use p hat minus p divided by square root of p. All right. So we got to calculate what? What do we have not calculated yet? P hat. Okay. Now this is what comes out nice. And then it's just plug and chug, right? P hat minus P divided by square root of PQ over N. So 0.75 minus what?
667.
Good, 667. So it's always our data minus the supposed middle, and then divided by the spread, which in this case is this weird ass thing. What was it, 84? That's a very small sample, by the way, so that explains why we get what we get here. Did what I did. What?
Well, it's like it's insane small. Feels like a really small number.
No,
I did that.
you did. I don't know. It depends on what you call small. It's not smaller than 1, and it's not bigger than 2. Anybody get that?
6, 1,
Yep. Okay.
4.
I don't care about it. So 1.61. So real quick, did anybody try to plug this in your calculator and not get 1.61? So everybody got 1.61? You're all like, there's a third option, Jeff. I don't want to say. All right, that's up to you. I was going to show you if you didn't get it, but if everybody's saying they got it, hey. So what do we do here? Did we find enough evidence?
Nope.
All right, and how do you know? Because we didn't quite. So you could do the visual. There's 161, right? We didn't get in there. We didn't find enough evidence. We didn't get far enough away. We can't say that the null dude's wrong because we got right in there. That's what the guy expected to happen, right? This is the unexpected area. We didn't get there. Damn it. But the nice thing is, what was our claim?
Oh,
Still calling me that. All right.
sorry.
It's okay. So, in this case, our claim is the null. So we're actually kind of happy that we ended up not rejecting the hope, right? Not rejecting the null hypothesis. I don't know if you guys are with me or not. And to be really, really honest, of course, scientists, they're happy either frickin' way. Somebody can go, I think it's really this, and then they do an experiment and they find out it looks like it's not that. That's amazing. What the hell is it? That's awesome. We don't give a shit. Like, we just want to know what it is. Okay. Sorry. I don't know if you guys know there's still flat earthers out there. Do you guys know that? So that kind of thing just makes me very sad. So if you believe there's flat, just keep it yourself, and you're in the right place. There's hope for you. Okay. Sorry. Just call me a globe earther. You globe earther. And in the conclusion, yeah, we didn't make it, so we have not found sufficient evidence to reject, because our claim was the null, reject the claim that the percentage of students who feel the semester should be shortened is 66.7%. And again, I got it on my answer case. I'm not going to write it down. I already wrote it down once. All right, so let me do this. I'm going to go ahead and give you guys the answer key. I'm going to re-explain which one passed Jeff. Thank God. I don't know about passed Jeff. Which one you got wrong?
3C.
So, correct this real quick. Yeah, this problem I changed a few times. So this was supposed to be 1684, is that what it was? Still averaging about a 97 on my answer keys. That's pretty good.
97 the answer.
Hmm?
Nothing, there's averaging 97 on the answer.
Yeah. Not too bad. Is that bad? I'm sorry if it's bad. I don't know, I was just making that up.
Made the correct.
Yeah. On a problem like this, I would probably say don't worry about the conclusion. It's enough work on its own. But this one you had to do 2 confidence intervals, right? So if you do all the work for one of them, all the work for the other one.
I have a question. How long would it take you to do this?
To make the answer key,
Yeah.
20 minutes. Of course, I'm the guy that made up the problem, so I mean shit. Give me a problem.
Sure.
it would maybe take me 30 minutes then if somebody else made the test. And again, it's what I do, so it's not even. It's like, ooh, you do this all the time, and you could do it. That's amazing, Jeff. Yeah. All right. So it's still wide open. If you have questions from that last quiz, if you have questions from homework, if you have questions from my answer key.
$78.
78 in the one about the sick days. This here? Yeah? Okay. So I got a question on 78. The mean number of sick days an employee takes per year is believed to be about 10. Right off the bat, we got what? What is that? The claim. We got the claim. So the mean is believed to be about 10. Members of a personnel department do not believe this. Actually, there's the claim. Members of a personnel department do not believe this figure. Okay, that's interesting. So what is the actual claim? The mu.
Not equal to 10.
Oh, somebody won.
Not equal to
Not equal to 10. I like. They surveyed 8 employees. Blah 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 blah. Oh, what's the main problem with this? And I think this is where I forgot to say. I think here we go. And the answer says you may assume that the only problem is normally okay. This book, they should just say it. I don't understand it, but oh well. Because obviously, does the sample size save us on this problem? What was it again, Sonny? Sample size does not save our ass, nowhere near. But it does say at the top, hey, it's a note. They should really just say it in the problem, but oh well. You guys all with me?
Yeah.
Okay. Was that your question? Huh? Oh, I see. All right. I would actually kind of like that if she's like, I can't do this problem, Mr. Waller. And I would have said, read the book. No. I mean, part of me is like, yeah, I don't blame you. I mean, that's the notes just sort of like floating up there. Okay. I mentioned this earlier, and I forgot to point it out that it does give itself that blanket statement. Yeah. But that was the only question on that one? Okay. That one I can't. No. Just by the way, real quick, I want to point out, this is an actual problem. I don't know if you guys noticed that. So, you're welcome that I did not assign that.
Thank you.
Yeah, there it is. Okay, so 85. Newly hired engineer hopes that it's shorter. Okay. She has 10 engineering friends and starts to blah, 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 blah. Okay. So, this one again, it's a t-score we have used, right? Because the standard deviation we're going to get is going to come from the sample. And they said earlier, a t-score distributions assume that it's underlying normal population. So, is there a specific question? So, I mean, the first thing you do is you throw all this in the calculator. Let's see. Can you do it?
I think, can you just go through the problem is the question.
Sure, yeah. I guess so. I mean,
Don't do it.
it is sort of my job. I appreciate that, Charlton, but I'll do it. Let's see. All right. What in the world? All right, sorry. I was looking at that poem problem. So the claim is the mean is shorter than 60 hours. So the mu is less than 60. So that's going to go where? We'll do this. Right? Shorter than 60 hours. Which one is that? Ha! So the ho is, I'm already writing it. There you go. Will it be one tail or two tail? How do you know? What are you looking at? Ha. It's less than, so it's one tail. Only care about down. Okay. Part B? Z or T, we already know this one. 1, the book says is normal. Secondly, we don't know sigma. So we're going to use t-scores. All right, so take a minute and, well, actually we can do part C, is the rejection region. What's alpha, do they say?
0.01.
Where do they say it's 0.01?
Didn't you say if they don't tell us?
I did say if they don't tell us, but I didn't say 0.01. 0.05.
Oh, 0.05.
0.05. I think the book says that somewhere, but I can't remember. But it did tell you, in fact, our first definition of unusual was 2 steps or more away, 95% in, 5% out. 0.05 is the standard definition of unusual. So if they don't give us an alpha, we assume it's 0.05. What's degrees of freedom? Man, we were all over. N is 10, so the degrees of freedom is 9. Yeah, it's always one less than N, or not always, but for us, it's one less than N. So can somebody look up and it's a one-tail test, right? .05, one tail. So which column are you looking in? .05, one tail, which column? Fourth column. And you're going to stop at 9. So 1.833. You guys all with me? Do I put 1.833 there and everything's good? Does that look okay? There we go. Okay. I could see in Sam's eyes, she's like, is he okay? No. How do I say this in words? If my T-star gets in there, how do I say that? If T-star is less than? Jeff. We can do what? Check. Okay. Why am I doing all this work here? You guys do part D. I'll stay. So what do you have to do for part D? You ain't got shit. So what do you got to do? Huh? One var stats. So you got to put that in your calculator. So don't say anything. Go ahead and do that real quick. I guess I should do it. Where's my calculator? Okay, cool. That's good. So either stat, calc, one of our stats, L1. See if we all get the same thing. I got that. Is that what you guys got? Oh, you're all like, yes. All right. So I got X bar is 57. I got S is 7.149. So what is the standard deviation of the sample means? 7.149 divided by the square root of 10. So I get 2.261. You guys all with me? It's riveting stuff, I know. So T star equals, help me set this up. What goes here?
X bar,
What goes here? Yep.
57,
57 minus
60,
60 divided by
2.2,
2.261.
negative
30, 15,
1.327,
11s. Huh?
negative 1.327,
Sounds about right.
fail.
Does everybody agree with that? And of course, we failed because we did not get far enough away. Far enough away was this. We didn't make it far enough away. We made it to about right there. So we fail to reject the null. Fail to write well. Okay. So what got us started was the claim. What gets us to end is the claim. What was the claim? Which one? The ha. So I'm going to use this language, not that language. It's that simple. Fail translates into
We have not.
we have not found sufficient evidence to
Reject.
meh,
Oh, to support.
support. Sorry, I gotta appreciate that moment of teaching excellence. I think it's this, Professor. Meh. Thanks for playing. To support the claim. It's like I became the Penguin from Batman. Support the claim that I don't remember what the claim was.
That is less than 60.
Yeah, the mean work week is shorter than 60 hours. Shorter than 60 hours. Shorter than, this says 60 hours. Okay. I love it. Such a wide range of emotions happening out there right now. Very often students don't believe me when I say I brought nothing. Except, everything. But I've got nothing in terms of presenting anything to you. So it's all based on your questions. So if you feel ready, you can always just head out. You don't have to sit here looking at me. If you don't feel ready, then ask some questions. And what I love is when I get nothing but people left just hanging out to see if anybody asks a question, then we all just end up like, somebody got to say something. One little thing, did I put, yes, I did, didn't I? Shoot. Did I have a question here about the types of error? Yes, number 4. How'd that one go? This is the boring type. This is the purely mathematical type. So on the actual test, I could have a problem, sort of like in the book, about like the sunken treasure or the procedure will go well, that kind of thing, right? You guys with me? If you've done your homework, you know what I mean. Okay? So I could certainly put that on there. Notice this too. None of you guys seemed bothered by this, but do you see how this problem I didn't give you A, B, C, D? Because I already did once. So I am definitely going to give you at least one problem with all of it spelled out. And then I might give you another problem where you just, same 5 steps, right? Okay.
Can we review 78 together just for fun?
78. Is that the one we just did earlier?
We touched on
Boop. It would work exactly the same way that 85 did.
yeah.
So I don't know what to tell you.
All right.
If you have an actual question, but again, what's the claim being made?
There's a hawk.
No. What's the claim?
Not equal to 10.
Yeah. They don't believe it, so not equal to 10. Is that the one we started somewhere?
It's a two-tail test, Bobby.
That's right, two-tail test. What's alpha?
It's supposed to be 0.05, but I did it with 0.01.
Ah, okay.
I did them all with 0.01.
I can't remember. I know the book says somewhere about the 0.05 thing, but
I asked someone else in the class and they said 0.01.
you can't trust those people. Thank you. All right, guys. So 78. Let's see. They surveyed 8 employees. That's our N, so we know degrees of freedom. And I'm going to have to use T-scores because I'm only going to have a sample standard deviation. I still have one person's key, so if they forget it, they're not going to get far. Oh, okay. Oh, yeah. Yeah. Oh, I got 2 people's keys. So 0.05, it's a two-tail test.
9 degrees of freedom. So,
7 degrees, right? Wasn't it 8 people?
oh,
Yeah. The claim was the mean is 10, but it was a sample size of 8. Another what?
Practice it.
Yes.
so T's 2.36.
Wait, is that the one I wrote on?
Thank you.
Sure. Sorry?
2.365 is T.
Yeah, because the degrees of freedom would be 7. Yeah, 2.365. That'll be my rejection region, right? Negative 2365 and positive 2365, right?
It's a fail.
Okay. All right. So again, you have to plug all this into list 1, do 1 more stats, get your X bar and your S. If anybody wants this further fleshed out, just tell me, but it's exactly like the problem we just did. It's exactly the same as this problem,
I
right?
did all these with 0.01.
Well, shite.
Number 2 on the practice test.
All right. So what part of this is giving you trouble? How do you check this one for normality?
It's because, I'm gonna be honest, you already saw my quiz score. Don't necessarily.
Oh, okay. So to check a percentage problem for normality, to see if it's normal enough, you check N, P hat, N, Q hat. For confidence intervals, because confidence interval, I don't know what P is. For hypothesis tests, we're assuming we know what P is. So here I have to use the hatted ones, right? We don't know what P hat is though yet, do we? What is P hat?
135 over 6.
Yeah, 135 out of 672.
2009.
201? Yeah.
Oh.
So then what's N times P hat? What's N?
672.
Right, 672. So 672 times 0.201. That'll be a little bit more than 135. You guys with me?
I don't have my
Oh, well, shit. Well, I got plenty. 672 times 0.201, just a little more than 135. 672 times, what's Q hat?
0.799.
799. And that'll come out to be 536.928, I think. What's important is they're both more than 5, right? At least 5.
You,
What does that mean?
normal enough.
Normal enough.
Your T-score, Z-score. Plus or minus 2.17.
So then you can do p hat plus or minus z square root of p hat q hat over n. It's just a bunch of plug and chug stuff, right? You got to look up the z score for 97% confidence. Can you draw a 97% confidence interval? What would be in here? By definition, there's 0.97. So how much is outside?
0.0125.
So JC,
Yeah.
if there's 97% inside, does that make sense? So it'll be 3% outside, so it'll be 1.5% there. And why do I have to do this? Because 0.03 alpha is not on our t-score chart. So I've got to do it the old-fashioned way. I've got to look up 0.015. Closest I can get, I think, is it. Yeah, there. So I get a negative 2.17 z-score. So that's what I'm going to put here. And the rest of it you can see on the answer key. Now it's just a bunch of plug and chug, right? Plug it in, chug it out.
The 47 and 9 is everything is, right?
Say again,
For
sorry?
the Q hat?
This guy?
Like, yeah, that's everything.
Yeah, it's just 1 minus this. Yep.
Now, your P hat is 0.2009, right?
Okay.
And then the confidence interval is plus minus 0.0335.
Okay.
So then you're not going out very far to anywhere, get near anywhere that Z.
See. Sorry?
So if your P hat is 0.2009, you're just going plus or minus 0.0335. So your range is 0.1674 to 0.2344,
Sure.
which is way, or nowhere near the plus or minus 2.17.
What do you mean? Well, 2.17, wait, why would it, okay. I don't understand. So we're about 3.4% above and below 20.1%. So I mean that's what it is. 2.17 is just the z-score. It's not a percentage or anything. There's no way a percentage could be close to this because it's more than 1. I'm not sure why you brought this up.
Because you're trying to get into the error, right? You're trying to see how far, if you get it to alpha. No?
I don't know what you mean. So 0.201.
No, this is just finding.
Yeah, this is a confidence interval. It's not a hypothesis test. Yeah.
Okay,
Yeah, but there's no rejection region or anything. Yeah.
gotcha.
This is descriptive.
Descriptive.
Hypothesis test is inferential.
I haven't had one.
Yeah. No, neither have I. I understand. Yes.
Can you show how to plug in the PHAT list? Like the error formula?
So I would first calculate the error allocated. So put 2.17. So we'll calculate this time. Square root. Okay, so you got this. So you don't want to close the parentheses. You need everything in there. 0.201 times 0.799 divided by whatever that is. There you go.
Oh, okay. Thank you.
Okay, sure. So you got the old school calculator that the square root doesn't grow. You just have to don't close that parenthesis. The minute you close it, you're outside of the square root. Yeah.
Do I have to redo all of those with the 0.05?
just have one. Well, it could change your conclusion on a few. Yeah.
Alright, be good, Pat.
Oh. Is that? Are you humming something from Frozen? Moana. Oh.
I did my 12-hour
Do-do-do,
peak shift
do-do-do,
yesterday.
do-do-do, do-do-do, something like that, right?
Uh-huh.
Okay. That's driving me crazy. No. I was trying to remember